haven't been recording this. I forgot to turn it on. I just turned it on now. Move this thing up a little higher. Get a little more room. So I'm going to graph it over here. And since my period is 120 degrees, I'm going to put that point right there. I know I don't need to go further right than that. Yeah, I might, actually. Nah, I won't.
Yeah, I only have to graph 4 points.
Okay. First of all, since we have a phase shift, the best way to graph this is to start at the first point where we would normally phase shift. In other words, normally we would start the cosine right there.
Right.
Now we're going to go 30 degrees left.
Left, okay.
And start it right there. Where am I going to end it?
120.
120 from 30. In other words, at 90, I'm going to end it.
90. Okay.
See why?
Uh-huh.
Because the period needs to be 120. So if I was just plotting phase shift only, I would start here, go down, end it back up there. That's what cosine of theta plus 30 would look like. Well, this 2 means that instead of going from 1 to minus 1, I've got to go from 2 to minus 2. So let's put minus 2 there. Now let me do this differently. I need more room. Let's call that 2 and this 2, minus 2. So, in other words, if I was plotting 2 cosine of theta plus 30, if I was plotting 2 cosine of 3 theta plus 30, then I would start here. I would break this from minus 30 to 90. I would break it up into fourths, and I would go through each of those points. Right?
Mm-hmm.
Only thing I have to do is move everything down by 1. First of all, let me draw this, because this can be kind of hard to see. So, first of all, if I take my period here and divide it up into fourths, that point right there is 30. This point here is 60. This is 0. So my non-vertically shifted cosine curve would look like this. Hold it. It would start at 2. And it will go down to minus 2 at this point. Come back up through that and end right there. That would be that curve right there. You see that?
Uh-huh.
Well, minus 1, I'm going to take this exact curve, drop everything down by 1. So instead of starting here, I'm going to start 1 rung lower. And instead of going down to minus 2, I'm going to go down to minus 3. So it's going to look like that. Plotting these can be a little tricky as to where you begin. And there's lots of different ways to plot it with a phase shift. I used to plot phase shift by plotting the unphase shifted curve first and then moving it left or right by the phase shift. I'm just trying to draw a parallel. But I've since discovered that this is a better way to do it. Find your starting point, add your period to it, that's your ending point, divide that section into fourths, and go from there. Anytime you have a phase shift, I believe this is the way you should do it. It's to find that starting point and ending point.
Okay.
Okay?
I agree, yeah.
Okay. So let's see. Gosh. This is very odd that they would do this to you. Almost looks like these problems came from a school system that used the other format.
Oh, really?
Well, yeah, because the B is inside the parentheses on all of these.
Mm-hmm.
See, in a school that uses this format, the phase shift is C divided by B. It's not C.
Oh.
But in this format, the phase shift is C, not C divided by B. So that's why it makes such a difference as to whether that B is inside the parentheses or not. So what's our first step here?
To take out the 2.
How do we do that? Yes, you're correct. That is.
Yeah. Do we have to?
Are we taking out a 2 or are we taking out a 1/2?
Yeah, we're taking out a 1/2.
Okay.
Or yes.
We're factoring out a 1/2.
Mhm.
What's left?
So it's 1/2.
This is always going to be
theta minus 60.
Well, if I wrote 60 and then I checked myself to see, well, if I multiply 1/2 by 60, I get 30.
Right.
That doesn't work. 60 doesn't work.
See.
We're dividing 120 by 1/2. When you divide something by 1/2, it's the same as multiplying it by 2.
By 2. Okay, so it's 240.
Okay, so there's the format we want. So, again, A is 1/2. B is 1/2, making the period what? This is a vital step here, what I'm doing on the left. You want to know what your period is before you start the graphic.
Right, is it... So the period, don't you...
What's the period equal to?
So do you multiply it by 2 then again? So it's like 480?
What's 360 by 2, so it's 720.
Oh, right, 360.
Because it's 2 pi divided by b, and 2 pi is 360.
Right, yeah.
Okay, so our period is 720. Our phase shift is right 240.
Right.
And our vertical shift is
2.
up 2.
Right.
So let's graph it. So let's see, I'm going to label this point 480. You will see why. Not 720. My first step here is going to be what?
To probably put the midpoint, so 2.
Actually not. You know, I like that as a last step. I know I said I liked it as a first step, but it got me confused. So I'm going to do it as a last step. I think it's less confusing if you do this plus 2 at the end.
Okay.
Not sure, but I think so. So the first step is to find out where our starting point's going to be.
And that's...
on the horizontal axis.
Is that at 240?
Minus. In other words, you're right.
Right, okay.
I screwed up here. I meant to label this 960. The reason being
Right, because you can add that.
Yeah,
Okay.
in other words, that's 240 right there.
Uh-huh.
I know my period is 720, so I know it needs to go from 240 to 960.
Right.
Okay? My amplitude is a half. I'll call that 1. This minus 1. So my amplitude's going to actually go from a half to minus a half before I do this vertical shift. Let's divide this 240 to 960 up into fourths. That's our next point.
So is it...
They're each 240. In other words, if I take 720 and divide it by 4, they're each 180.
180, yeah.
Excuse me. So this is 420. This is 600, and this is 780. Right?
Uh-huh.
Now they're each separated by 180.
Mm-hmm.
Yeah. And I drew this incorrectly. That's not the same length as that. That's 180 to there. That's 240. But it's okay. We got it labeled right.
Mm-hmm.
Whether the graph is perfect or not, I don't know. So if I'm graphing just this part of it, without the +2, let me go ahead and graph that. Starts here because it's cosine, goes through there, only goes down to there, comes back up through there, and goes, this is why these are hard to do. Starts right there, right? I started it at the wrong spot. You got to start it at your starting 240 spot. And then it goes through there. It hits right there at the 1/2, comes back through here, and ends right here. So if I was not accounting for the vertical shift, it would look like this. So now I want to take this graph and move it up 2 units. Well, that means I need to go up to 2.5.
Mm-hmm.
And it's going to go from 2.5 to 1.5.
Mm-hmm.
In other words, the distance is still 1 between the top, the highest point, and the lowest point. So it's got to go from 2.5 to 1.5.
Mm-hmm.
I could put a new line of symmetry in there to make it easier to graph, because I know it's got to go through the curve there. It's got to hit bottom there. It's got to come back through the curve there. And it's going to go down so. Here's what it's going to look like. And now we can erase the bottom one. We can see that this looks just almost perfectly parallel to this. I don't need the bottom one. That's our answer. And that's the way I would probably do every one of them, is following a pattern exactly like that.
Okay.
Okay?
Mm-hmm.
In other words, this stuff on the left, you want to do that for every one of them, and then find your starting point and your ending point.
Right.
All right. Well, we probably only have time for maybe one more.
Okay.
Okay, let's figure out how to do these. Let's take the one on the left.
Okay.
What's the period? Let's go in order. What's A?
A is it point? Is it?
It's half of 0.1.
Right.
What's half of 0.1? 0.05.
Mm-hmm.
If you take 0.1 and divide it by 2, you get 0.05.
Okay.
Okay? In other words, we get A by taking the highest number, subtracting the lowest number, and dividing by 2.
2. Okay.
Okay? B. Well, in order to get B, we need the period. We can read the period from the graph. What's the period?
Is it...
Go peak to peak. This peak to this peak here.
So, is it 6?
Well, it's 7 out to this peak. It's minus 1 back to that peak, so it's 1 plus 7. It's 8.
Oh, 8. Okay.
In other words, you want to look on the graph and count how far it is from this point to this point here.
Right.
Peak to peak.
Peak to peak, okay.
Okay, or if you don't have peaks, starting point to the next starting point. In other words, if I'm looking over here, I got peak to peak I can use over there also. But I could also use this point to this point. In other words, go one period out. So if I know the period is 8, and the period is equal to, or B is 2 pi over the period, that's what B is, pi over 4. Now normally B is a number and the period is in radians, in other words has the pi on it. But not always, and definitely not in this case. Notice that the x-axis is not in radians, it's in numbers. So our period is a number, which is going to mean, since our period is equal to 2 pi over B, or B is equal to 2 pi over the period, we've got B equals pi over 4. Okay? Let's talk about C. What is the phase shift from what kind of a function? Cosine. First of all, you have to figure out whether you're talking cosine or sine, and then figure out what the phase shift is.
Well, it's cosine, right?
Couldn't be either, actually. Notice that it's a cosine curve shifted 1 to the left, or it's a sine curve shifted 5 to the right. Because if I start right here, that's a sine curve. The lower phase shift is the one you should use. The least phase shift is minus 1, is less than plus 5. So we're going to use cosine, and we're going to use a phase shift of minus 1. So C needs to be minus 1. Okay? I should have said we're using a phase shift of 1 left by 1, which makes C minus 1. What is D? Take your maximum, add it to your minimum, and divide by 2.
So 0.35?
0.25. 0.3 plus 0.2 is 0.5. Divided by 2 is 0.25. The halfway line between 0.2 and 0.3. Okay, so we got everything we need to write our equation.
Right.
I mean, we've got A, B, and C, and D. So our equation must be what? 0.05
cosine pi over 4 parentheses x minus 1
plus 1.
Plus 1?
Because C is a minus 1 and it's x minus C.
Okay.
So it would be x minus the minus 1, giving us x plus 1. And what's the last part?
Right. And then plus 0.25.
That's it. That's how you do it. In other words, when you have the graph and you need the equation, figure out what A, B, C, and D are. And to figure out B and C, You need to figure out the period and the phase shift before you can even figure out B and C. So you do the same thing over here. We can figure out A, take your high point minus your low point. Well, they're telling us that that's the line of symmetry right there. So you go from there. All right? Okay. Well, good luck on this test.
Thank you.
pretty heady stuff. But once you actually understand it, it becomes very, very manageable.
Right, I agree.
I mean, it's very, very doable going either way, going from graph to equation or from equation to graph. All right. Morgan, I will talk to you next time.
Okay. Oh, and do you know what my number is? Like, you know how? Yeah.
Your balance?
No. Like when you type in.
Yeah. I do. It's not. I know probably the first time you looked, it was probably said private, requiring a password, but I changed it after I got your message, figuring it must be private. It's ID 35. So if you go up and you change whatever you're looking at, in this case 66 to 35, it brings up your page. And these should be playable now.
Okay. Perfect.
If you find one that says private, let me know. Every now and then YouTube makes a mistake and changes my publics to private, and without letting me know. And that's what happened on this one, is they had changed your previous one to a private. I had to go in and change it to public so that you could see it. And there is no password.
Okay, so yeah, I just typed that in.
Yeah, once you get into this page here, ID 35, you should be able to view all of your old ones.
Okay, perfect.
You can see it, you can probably play it. If it shows up black, it's probably not playable.
Okay.
Okay?
Okay, thank you.
All right, Morgan. Have a good one. Talk to you later.
Thanks. Okay, bye-bye.